Oh, hi there guys. How's your day? I think you are here to learn something. What about vector components method? Seems interesting, right? Let's not prolong it. Let's get to the video. Welcome to General Physics 1. I'm Ruel Labore from 12 STEM Hook and I'm here to discuss the topic all about vector components method. A vector quantity has both magnitude and direction. To find the resultant vector, we will use these two. The magnitude of a vector is the length of the vector. In magnitude, we will use the Pythagorean theorem, which has the formula of r squared is equal to x squared plus y squared, or we can simplify it as r is equal to square root of x squared plus y squared. For direction, we will use the north, east, south, and west, and we will use the tangent function, which has the formula of theta is equal to tangent opposite over adjacent. Let's have the given example. Our vector 1 is equal to 8 meters west, vector 2 is equal to 6 meters north, vector 3 is equal to 12 meters, 50.3 degrees south of east, and for the last, vector 4 is equal to 15 meters, 33.8 degrees north of east. Now let's take a look on x and y components of each vector. For vector 1, we have the x component, which is negative 8 because the direction is on the left, which could be negative. And for y components, we have 0 because it's only on single direction. For vector 2, for y components, we have 6, and for x components, we have 0, which is also on single direction. So in this case, we will have to find the other x component and y components of each vector. To find for x and y components of vector 3, we have the given of 12 meters, 50.3 degrees south of east. Now to find the x component, we will use the equation cx is equal to c cosine theta. By substituting, cx is equal to 12 meters cosine 50.3 degree. Now for the final answer, we have the cx is equal to 7.67 meters. For y components, we will use the equation cy is equal to c sine theta. By substituting, cy is equal to 12 meters sine 50.3 degree. And for the final answer, we have cy is equal to negative 9.23 meters. For vector 4 with the given of 15 meters, 33.8 degrees north of east. To complete for x component, we will use the equation dx is equal to d cosine theta. dx is equal to 15 meters cosine 33.8 degrees. Now we will have the answer dx is equal to 12.46 meters. For y components, we will use the equation dy is equal to d sine theta. dy is equal to 15 meters sine 33.8 degrees. Now we will have the answer dy is equal to 8.34 meters. Now, our x and y components of each vectors are complete. We will sum up it. For x components, we have the total of rx is equal to 12.13. And for y components, we have the total of ry is equal to 5.11. Now, we can use the Pythagorean theorem. R is equal to square root of x squared plus y squared. By substituting, r is equal to square root of 12.13 squared plus 5.11 squared. R is equal to square root of 147.14 plus 26.11. R is equal to square root of 173.25. Now we'll have the answer r is equal to 13.16. Now we will use the tangent function, which has the equation of theta is equal to tangent opposite over adjacent. Theta is equal to tangent y is equal to x. Theta is equal to tangent 5.11 over 12.13. Now we have the answer theta is equal to 22.84 degree. Now we can simplify that r is equal to 13.16 meters, 22.84 degree north of east. Now to check our answer if correct, we will reverse the direction. Theta is equal to tangent opposite over adjacent. By simplifying, theta is equal to tangent 12.13 over 5.11. Now we have the answer theta is equal to 67.16 degree. And our r will become r is equal to 13.16 meters, 67.16 degree east of north. If we sum up the two angles, we can classify it as 90 degree, which is equivalent to 1 quadrant. Now we can determine that our angle is correct.